Hello everyone. In this video, we are going to discuss the numerical from your unit number 1, that is vector analysis. And this numerical is basically related with the vector components. So we are going to see that one. And if you have any queries, you can drop me a mail onto my this email ID. Okay, so now we will begin with this numerical. So in this numerical, we have been given with the two vectors, that is vector m and vector n, which is basically expressed in rectangular coordinate system. And very firstly, we have to find out what is the vector component of vector m, which is parallel to vector n. So this is also said to be what? It can be also written as vector projection of your vector m to along vector n. So these are the one and the same thing. So vector component of vector m parallel to vector n is equals to vector projection of vector m along vector n. So these are the one and the same thing, and that we have found out earlier. So what is that one? So it should be equals to your given vector m having the dot product with the unit vector of your second vector, that is vector n here in this case, and it should be multiplied by means of the unit vector of your vector n. Okay, so we will see that one. So what is the simplification? So very firstly, write down that vector m as it is. See, you can go by two methods. Very firstly, you can solve this vector an, what is unit vector an, and then you can simply put the values, or directly based on your practice, you can go with this putting the value directly within that numerical. So we will put that value directly. So what is vector m? We have that vector m is equals to 10 ax cap minus 8ay plus 5az cap. So this is your vector m, and it should have a dot product with what? Dot product of your unit vector along n. So what is unit vector for that vector n? So vector n is equals to here in this case I am going to write. So vector unit vector an is nothing but what? Your given vector n divided by its magnitude of the vector n. So here in this case I am going to write directly over here. So what is your vector n? We have that to be 0.1 ax cap plus 0.4 ay cap plus 0.2 az cap divided by its magnitude. So what is the magnitude of vector n? So we have that to be the square root of 0.1 square plus 0.4 square plus 0.2 square, that to taken in the square root. So take it onto one bracket. This also shows you what? That shows you the scalar projection of vector m over vector n. Now next is again rewrite for that vector unit vector along n, this one. So what it should be? So in similar fashion we can write your given vector n, that is 0.1 ax cap plus 0.4 ay cap plus 0.2 az cap divided by its unit vector, sorry, divided by its magnitude, not unit vector. So that shows you what? Unit vector of given vector n. So 0.4 square plus this will be 0.2 square. Okay, now we are done with this writing. Very firstly, we have written about your given vector m as it is, and then we have taken its dot product with unit vector along n, and again we are going to multiply it by your given vector unit vector n. Now simplify that one. So what will be the simplification of the very first bracket? So simplification of first bracket is nothing but what? The dot product in between these two given vectors, that is this 10 into zero point 0.1. So that will be what now? So that is 10 into 0.1 is 1. This minus 8 into this 0.4. So we will have that to be what? Minus 3.2. and this 5 into this point 2. So that will be what now? That will be plus 1 divided by, for now you just give this square root as it is, or you can simply multiply this square root into this square root. So what will happen? This square root and this square root, it will get cancelled out, and you will be having this much value, that is 0.1 square plus 0.4 square plus 0.2 square, since that square root is now squared. Okay, now what is left? This given vector n is left in the numerator. So that will be what now? 0.1 ax cap plus 0.4 ay cap plus 0.2 az cap. Okay, now simplify that one. Either you can take this ratio and then multiply with respect to your given vector, so that you will find your answer. So here in this case I have taken that ratio and then I have multiplied that by your given vector n. So you will find that value to be what? Minus 5.7142 into your given this vector. So that is what? 0.1 ax plus 0.4 ay plus 0.2 az. I have written this bracket over here. It is not necessary. This bracket is not necessary. It should be what now? 0.2 az cap. Okay, fine. Now multiply that one, so that you will find what? Vector projection or vector component of vector m, which is parallel to vector n. And answer is what now? After that multiplication, you will find that to be minus 0.5714 ax cap minus 2.2856 ay cap minus 1.1428 az cap. So this is what? This is your vector component, or you can say vector projection of vector m over vector n, or vector component of vector m parallel to vector n. So these are the one and the same thing. You can say this to be the projection of this vector onto this vector, or component which is parallel to this vector. So this is your very first part of the numerical. Now we will be moving on to the second part of the numerical. Now in the second part of the numerical, we have to find out what is the vector component of vector m which is perpendicular to vector n. See this one. What is vector component of vector m which is perpendicular to vector n? So it is given by means of this factor, that is the component on which it is to be made perpendicular. So unit vector of that vector. So which is that vector now? We have that vector to be vector n. So it should be what now? It should be your unit vector along that n, which will have the cross product with what? It will have the cross product with respect to your the given two vectors, that is vector m and vector n, divided by again the magnitude of your second vector, that is vector n here in this case. See, listen again. what is vector component of vector m which is perpendicular to vector n. So what we have to do, we have to take very firstly the unit vector of your second vector. So that we have taken over here as this vector n divided by its magnitude. Then we have to take its cross product. So this is the second step. And what we have to do, we have to take the cross product in between the given two vectors, that is vector m and vector n, and then divide it again by means of using this magnitude of your second vector. So that's what we have done over here. So this is how you are going to find out the vector component of one vector which is perpendicular onto the another vector. Simply you just take the unit vector of second vector, then have the cross product with given two vectors, and then divide it by using the magnitude of second vector. So this is what you can say it to be the vector component of one vector which is perpendicular onto the second vector. Now we will simplify that one. I am going to rub it out now. So we will break down this given equation into two parts. Very firstly, we are going to find out what is the cross product in between the given vectors, that is vector m and vector n. So what is that cross product? By using the property of the cross product, or you can say now, very firstly we are going to find out what is that given m cross n, and from the property of the cross product, what we have that to be this ax, ay, and this az. Since it is expressed in terms of the Cartesian or rectangular coordinate system, we have the magnitude of this vector m, which is what? This is 10. Then magnitude of m in y direction, that is -8, and magnitude of vector m in the az direction, so that is what? 5. Then we have the magnitude of that vector n along x is equals to what? 0.1. Then magnitude of that n along that y direction, that is to be 0.4, and then magnitude of this n along z direction, so that is to be what? Now we have that to be the 0.2. So we are going to simplify this determinant to get our answer. So what it will be? So well, I hope you know about that calculations, so I am not going to write into the details. So ax cap multi, then within the very first bracket you will find that -8 into this 0.2, so that will be what now? -1.6, then minus this 5 into 0.4, so that will be what now? That will be 2, plus ay into this 5 into this 0.1, so that will be 0.5, then this 10 into this 0.2, so that will be what now? That will be 2, plus az into this 10 into 0.4, so we have that to be the 4, then minus this -8 into 0.1, so that will be what now? So that will be minus of 0.8. Now simplify that one so that you will find the cross product in between that m and n. So the value of that cross product in between vector m and vector n is equals to, you will find that to be the -3.6 x cap minus 1.5 ay cap, and lastly that will be what now? That will be 4.8 az. So this is the very first element for your this answer. Now next is what? We are going to find out the cross product in between this vector n and this cross product of the bracket, that is m cross n. Okay, so we have this as your vector m cross n. Now we will find that n cross this m cross n. So from the previous slide we have the cross product in between m and n which have this value. Now we are going to find out what is the cross product of your vector n with respect to this bracket of the cross product. Okay, so since again we are dealing with this rectangular coordinate system, so we are going to write the determinant for that one. So that is ax cap, ay cap, and az cap. Now, what is this very first one? M cross n. So we have the value for that m cross 1, m cross n, and you just write the magnitudes for that one. So that is what? Minus 3.6. Then here we have that to be minus 1.5, and here 4.8. Now, what are the magnitudes for your vector n? So we have this to be 0.1, then over here 0.4 magnitudes of n, and we have this value to be 0.2. Now we are going to simplify that determinant. So this will be ax over here. Now this minus 1.5 into 0.2. Sorry, uh, what is that one? Vector n, it should be very firstly. Sorry for that. Sorry for that. Since that cross product in between is in between vector n and m cross n. So very firstly write for that vector n. So what is that vector n over here? Sorry for that, 0.1. So it should be 0.4 over here, and this magnitude of vector n along z direction. So that is equals to what now? 0.2. Okay. Now we are going to write the magnitudes of m cross n. So what are that magnitudes? We have that to be the minus 3.6. We have the magnitude for this, that is equals to minus 1.5, and we have the magnitude for that z, so that is equals to what now? 4.8. Okay, now this is the correct one. Very firstly write for this n, magnitudes for that n, and then write for the magnitudes of that m cross n. Okay, now simplify that one. So this will be x, then this 0.4 into 4.8 will be what? That is 1.92. Sorry, this is what? 1.92. Then this 0.2 into minus 1.5. So that will be what now? Minus 0.3 plus ay into this 0.2 into minus 3.6. So that will be minus 0.72 minus this 0.1 into 4.8. So that is what? 0.48 plus this az. Then this 0.1 into minus 1.5. So that is what? Minus 0.15 minus this minus 3.6 into this 0.4. So that is what? Minus of 1.44. Now simplify that one so that you will find the value of your that n cross m cross n. So you will be getting that value to be 2.22 ax cap minus 1.2 ay plus 1.29 az. So we have the value for this n cross m cross n cross. So this is the second element that we will be using. Okay, now we will move on to the next part. And yes, here itself we are going to write what is the magnitude of that vector n. So as we know that magnitude of given vector is nothing but what? Square of their magnitudes along x, y, and z direction. for rectangular system. So we have that to be n is equals to 0.1 square. Then here that will be 0.4 square, and here we will have that to be the 0.2 square, which is taken in the square root. And after simplification, you will find that magnitude of vector n is equals to 0.4582. So we have the second answer, or you can say the third element that we will be using, magnitude of that vector n, which is equals to 0.4582. Now we are going to make use of these values that we have found. We are going to use this n cross m cross n divided by this um, n cap. Okay, so we will see that one. Now, as earlier said, so vector component of one vector onto another vector is given by means of this. That is cross product of your unit vector of second vector multiplied by this one. Okay, so we have that values and we are going to put that one. So we have that n cross m cross n, that is equals to what? This one. Just I'm rewriting it for you. N cross m cross n divided by what now? We can also see it to be the square of this n square. Okay. Now, what is that n cross m cross n that we have found in the previous slide? We have that value to be 2.22 ax cap minus 1.2 ay and then 1.29 az divided by square of the magnitude of n. So we have that magnitude of n to be what? 0.4582 square. And if you simplify that one, so you will get your answer, which is equals to 10.57 ax minus 5.71 ay plus 6.14 az. So this is what? This is your vector projection of vector m, which is perpendicular to vector n. So this is our final answer. Now another I'm going to tell you, there is cross check, how to find out whether you are correct or not. So that cross check is not necessary that you should write in your examination. Actually, we are done with this numerical. That is that cross check, that is simply for your information purpose. So I will share it onto the next slide of the same video. So this is how you can go with the cross check. So here we have the vector m, and that vector m is basically divided into two parts, that is component of vector m which is parallel to vector n, and component of vector m which is again perpendicular to vector n. So we have these two components. So from this you can get the value of the component of vector m which is perpendicular to vector n. And how is that one? So that is the very much basic. So we have the component of vector m which is perpendicular to vector n is equals to what? Your given vector m minus component of vector m parallel to vector n. So we have the value of that vector m which was given in your numerical, and that was equals to what? This 10ax minus 8ay plus 5az, and we have to subtract the component which was parallel to vector n. So that was the very first part of your numerical that we have found, and that value we already have, which is equals to minus 0.5714 ax cap, then minus 2.2856 ay minus 1.1428 Z. This is just for your cross-checking purpose. It is not necessary that you should write in your examination. Now, if you simplify that one, you will find that both values are equal. So this is how you can get the confidence whether you have gone in a correct way or not. So if you simplify that one, so you will find that subtraction to be 10.5714 AX minus 5.71 AY plus 6.14 AZ. So this is just for your cross-checking purpose. You will have the both answers to be same. But for theory exam point of view, you just go by previous method. Okay. With this, we have ended your numerical from vector analysis. You can appreciate my efforts by hitting the like button and share it among your friends. Okay. Thank you.